Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post, the second in the Laws and Disorder series. This one is Hyrum's law. Every observable behavior of your API is a contract someone depends on, and in the age of AI agents, the question becomes who actually pays when it breaks. Hyrum Wright noticed around 2011 that even internal library changes that should be invisible kept breaking something somewhere. The law, with enough users, it doesn't matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. The keyword is observable, not documented, observable. The classic example is a list. Your docs say the order is unspecified, but the implementation has returned it sorted for years, so someone wrote code assuming sorted order. The day you truly randomize it, per your own spec, you break them. You were right on paper and it did not matter. And XKCD captured it perfectly. Someone holds down the spacebar to keep their room warm from the CPU heat, and the moment you optimize it, you've broken their workflow. Here's the part I learned the expensive way. Running API strategy at a large company, we did what almost everyone does. External APIs got the documentation, the versioning, the deprecation notices. Internal APIs were second class. But a broken internal contract caused just as much damage. Sometimes with a larger blast radius because internal callers had fewer guardrails. Hyrum's law does not check whether an interface is public. All APIs are contracts. Ever been frustrated that a cloud provider takes years to deprecate anything? Hyrum's law is the reason, and it's a feature. With enough users, you can't know which observable behaviors have become load-bearing, so you keep them, sometimes bug for bug, and deprecate on long telegraphed timelines. That caution isn't sluggishness, it's what reliability looks like from the inside. You might ask, is the Amazon S3 example fair? That was a strengthening, not a break. Exactly, and that's why I use it. In December 2020, S3 moved to strong read-after-write consistency for all operations, at no extra cost. It could only remove surprises, never add them. That's the safe kind of change a huge platform can make, the opposite of removing a behavior someone quietly observed. This diagram is the heart of the AI twist. On top the old world, an API change causes a loud break. A developer fixes it once with a standard library and it's stable. On the bottom, with agents, the same change makes the agent write glue on every call. It works, but cost and latency rise and reliability falls. A loud break fixed once versus a quiet workaround paid for on every call. So here's the forward-looking part. And this is reasoned analysis as of 2026, not a benchmark. Increasingly, APIs are consumed not by a developer writing a client, but by an AI agent through layers like MCP. When an agent hits a changed API, it can generate its own glue on the fly, so the user never notices the break. That resilience is real, but the workaround runs per call, so you pay in latency and spend, and it's bespoke, non-deterministic code. Agents turn a hard, visible failure into a soft, recurring tax you might not see on the invoice for a while. So doesn't MCP and agents make versioning obsolete? It's the opposite. The abstraction hides the break, which removes the forcing function that used to make you fix the root cause. Agents make API discipline matter more, not less, precisely because the failures they paper over are the ones that used to force the real fix. So how do you apply this on AWS? Version explicitly with API gateway stages. So a change is a new version consumers opt into, not a silent mutation. Test the contract, not just the code, with consumer-driven contract tests. Deprecate on evidence using real usage telemetry, not what the docs say is safe, and apply all of it to internal APIs too, because Hyrum's law does not care about the org boundary. This is the canonical source, hyrumslaw.com, the one-line statement of the law that this whole post rests on. It's about as concise as a source gets, and it's worth seeing in its original form. And here's the XKCD strip I mentioned, number 1172, workflow. It's the spacebar heating joke that captures Hyrum's law better than any spec ever could. The point of the joke is that it isn't really a joke. Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly or head to my blog at schristoph.online. Let's keep in touch. Take care.